All right. So let's see. So I wasn't recording. So what did we add here? Talk about the hydrometer. So do not test if water was just added. Measure specific gravity of the fluid. Sulfuric acid has a higher specific gravity than water. So a charged battery is going to have a higher specific gravity. A discharge will have a lower specific gravity. And hydrometer readings fall within these range. Then I was talking about, why couldn't you say something sooner, by the way? Hydrometer readings must be temperature corrected. Must be corrected. So we are going to, and that is based on temp of fluid, not ambient temp. So when you do that, don't pull out your phone, your watch, you go, well, it says it's 83 degrees, so I'm good. You got to figure out what the battery is. Now, if the battery just came in from a flight and it's sitting not far from the engine, the battery is going to be pretty dang hot. So you got to be the temperature of the electrolyte, not the surrounding air.
So you take one of those temperature guns or thermometers?
Well, that's a good idea. Infrared temp gun. The nice hydrometers that seem to last exactly 1 day here, because I found one and I brought it out and it lasted 1 day. They have a glass. They're glass, and inside they have a glass hydrometer that floats in the fluid at the appropriate level, and built into it is a thermometer. So
what happened to make it last 1 day?
It's the typical, it wasn't me, it was here when it broke when I got here, so I don't know. Like, yeah.
What would be considered the ambient part?
Ambient's what we are here. So if an airplane just came in from a flight and you wanted, and that actually, realistically, if you're going to do an annual inspection on an airplane, the first thing the inspector does is they go get the airplane, they go out and they run it up. So we're going to check power, check mags, check all the stuff on it, check all the systems. We're going to roll up to the hangar door, and usually your junior mechanics are waiting there with wrenches, screwdrivers, and a compression tester and spark plug tools to get the plugs out, check the spark plugs, right? So the engine's really good and hot. You do the compression check, and you're like, well, might as well do the battery. So at that point, you pull the battery out, and let's say it's a nice 60-degree day, and is the battery going to be 60 degrees? No. So the ambient is 60 degrees, meaning the air around us, but the battery is 90 degrees. Well, you have to base that on the 90-degree battery, not the air that is around you. All right. Not the ambient temp. Let's see. Check this right here. All right, so there's our correction chart. Out of 4313, table 11.2. This is out of 4313 because that's my go-to because it is acceptable data, as your textbook is not. And let's see. These, we'll talk Fahrenheit because, doggone it, we're Americans. And if we look at all of the correction, here's the correction. What is the one temperature that does not need to be corrected? 80 degrees. Well, I guess we could say, we could extrapolate. What if it's 82 degrees? Or 86?
-2.
So I don't know. You got to extrapolate that out. And often you're expected to extrapolate. So if it's like 85, yeah, I would go right in the middle, 85. So if it's 80, there's no correction. Everything else has a correction. What if it's between the two numbers? Well, what's between 0 and 4?
2.
There you go. All right. So at 80 degrees, there is no correction. So I don't know. You could probably say, well, 80 to 85, there's no correction. Do what you want on that. The tools aren't that accurate. All right. Your textbook does state that there's no correction needed between 70 and 90. But 4313 says 80 degrees. So AC 43.13. no correction. Needed at 80 degrees F. Textbook. States no correction.
I think even the manual is the same way. It gives a chart, but it says in general 70 to 90.
Yeah, no
something
correction
like that.
between 70
Pretty big difference if they say that.
to 90.
Well, what did you tell us, sir, if we go into a workplace and say, well, the textbook says...
Nobody says that. What takes precedence?
4313. Manual.
Yes.
Manual. But yeah, the manual says between 70 and 90.
Well, I don't know all the manuals. But if the Gill manual says 70 to 90, then that's the authority right there. I just didn't have it when I wrote this. All right, so let's see. Let's do an example. Example. All right. We have a hydrometer reading. So reading is 1.240. Outside temp. Of 80 degrees. Battery temp of 110 degrees. What information do we need off that?
Battery temp of 1.
The battery cry temp.
Battery cry temp.
Somebody sent me a link today of a coffee cup. It said something about, I don't know, it was funny because it was, but not. It was like, contains the tears of AMP students. More like contains the tears of the teacher. All right. So what are we going to do?
Go to our chart.
Go to our chart. Okay, go to our chart.
11-2.
What do we need? The 110 or the 80? 60. 110. What does 80 have to do with something? Where do I use that?
Nowhere.
Never. We don't care. So 110, we get right there. 110 says
Plus 12.
plus 12. So we had 1.240 plus 12. So that'll be 13.240 is my correction, right?
The battery's charged.
Points to be subtracted. But they're added. Yeah, it would be
0.12.
If it's hotter, it'll be less dense.
That's right. 12.000. So the specific gravity would be 13.240.
Yes, denser than lead.
It's 1200.
Try to put your finger into it. All right, that is not correct. That would be wrong because what was a fully charged battery?
1.300.
1.300. So we know that to be. Stop doing that. Dang it. So that would be bad. I wanted this. Erase all ink. All right. So back to this. Again, I'm going to go back to just using the damn board behind me. Life was easier. 1.240. And we have a correction at 110. It says plus 12. So that is
1.360.
0.12.
Oh.
I'm sorry, 0.012. 0.012. 0.012. Otherwise, it would. If I would have did 1.240 plus 0.12, out at 1.36. Is that?
That's above.
That's above the allowable, right? So we know that didn't happen. So there, 1.240 plus 0.012. The answer is 1.252. Does that make sense?
Yes.
Is that within the allowable?
Yes.
What state of charge did I go from?
Medium.
High, medium.
Low, medium to high. To
High medium. High medium. Oh, yeah, low medium. Yeah, it's 2.7, 240. So low, kind of medium to
Low to mid.
mid medium.
Medium. medium meat.
That's like me. I wear an extra medium.
Extra medium.
So we went from right here, the 1.240, to 1.2, I forget, 525. So right about it, a medium. Who said medium? Yeah, very good. You were correct. So medium.
Versus medium short.
All right. Let's see. What if we had a hydrometer reading of 1.275, and what temperature do I want?
140 degrees.
No. What temperature am I?
You want us to pick a temperature?
No. Where do I take the temperature? Temperature
from
of what?
from the electrolyte.
Electrolyte. I'll have an electrolyte temperature of
Negative 30.
60 degrees F. 60. Well, that would be typical for here in the winter time for an aircraft that hadn't run. So what is that?
75
Minus
0.08.
8.
0.008.
0.008. Which gives me 1.267. So we went from
Low, high to medium.
1.275 to 1.26. So kind of a high state to sort of a medium again. So we ended up medium. All right. Let's see. So we did the examples. What do we do with that electrolyte we just sucked up into the hydrometer?
Put it back in the same cell.
Put it back in the same cell. So I'm going to say fluid because it's way faster than running electrolyte, and save time, save world. Yes.
So why does it adjust up or down if it's hot or cold? What's the reasoning behind that? Does that matter?
Well, it matters because you want a correct reading.
Right, but like.
Why did it change?
Why does the specific gravity need to be increased when it's hot and decreased when it's cold?
Because we're looking for the state of charge of the battery, and therefore it's the hydrometer reading that gives us the proper state. So when we look at it, we say, oh, it's 1.240. Well, that's kind of low, but wait a minute, based on the temperature, that's a pretty good battery.
Okay.
Or if we said, oh, it's 1.3, that's fine, but I'm going inside because I'm freaking cold right now. Well, maybe it's not fine. We subtract enough points. It's like, that's actually kind of a low charge. So that's why I want to do it. Put fluid back and do same. Cell.
So fudge your numbers.
Yes, we don't. They don't interact. Obviously, check all cells, not just one. All of them need to be checked. A difference of 0.050 between cells indicates battery. See what you do with that one. Battery is near end of life. All right, I think I covered most of this. So let me just make sure I did. How many volts per cell?
2.1.
Okay. 2.1 volts per cell. All right. Capacity. How do we express capacity?
Amp hours.
Okay. Is in amp hours. Capacity is in amp hours. Let's see. What is the formula for amp hours? It is amps
Times
times
time.
hours.
Or time in hours.
Amps times hours. How many amps did you draw over how many hours?
And it's when they do it, it's actually across 4 hours, and they just well,
Yeah, so now, it doesn't have to be the exact same thing. I think it should be, but for example, you're doing an amp hour capacity check on the NiCad battery that you have in the lab. And Duke, what was your example? You had roughly.
110% state charge.
No, what were your time? You did like 45 minutes?
45 minutes at 4.1 amps
Okay, so you had 4 amps
for 45 minutes.
times 45 minutes. And then you had, what?
6.4 amps at 3.6 hours.
6 amp times, what was it?
3.6 hours.
Well, we'll say 3.25 hours. How many amp hours did we get out of this battery?
That was 20.
This one here. This is my example. How many amp hours did we get? All right, so this is what we did. We had a battery, had it on the table, and for 45 minutes we pulled out 4 amps, and then for 3.25 hours we pulled out 6 amps. Well, that's 45 minutes is 0.75. So it was a total of how many hours? 4 hours, okay, but you have to break it up into blocks. So 4 amps times the time. So what is, I think, 4 times what? 0.75 equals, so we had 3 amp hours, and then we did another 6 amps at 3.25 hours. And how many amps do we get there? 19.25 amp hours.
19.5.
I think I got actually 19.5. Yeah. 6 times 3.25 is
Yeah.
19. So how many amp hours did we get out of the battery?
22.5.
So we got 22 point, everybody following? Because the outline looks weird. We got total of 20, oops. Total, what did we get?
22.5.
Total of 22.5 amps. And how many hours?
4 hours.
4 hours. So how many amp hours did we get?
5.625 amp hours.
Oh, we got 22 amps at 4 hours. So that's 22 point.
So that's 22.5 amp hours.
Oh, yeah, we did the amp hour, sorry. Amp.
Okay.
I forgot, we totaled it up. So 4 amps at 45 minutes equals 3 amp hours. I forgot. There we go. And 6 amps at 3.25 hours equals 19.5 amp hours for a total of 22.5 amp hours. What if this was a 25 amp hour battery?
Not 100% charge.
90%.
25 amp hour battery. Then what is my percent charge?
90%.
And how do we get 90%?
22.5 divided by 25.
22.5 divided by the 25 is how much?
90%.
Then it is 90%?
Yes.
90% charge. You follow? Okay. Let me see, where was I? So, all right, batteries, 25 amp hours. We talked about the C rate. So,
Commissioner,
Yes.
I don't mean to interrupt.
But you just did. Dang it.
Yesterday you gave an example similar to that one where it was 2 amps for 30 minutes and 4 amps for 30 minutes equals 6 amps for 1 hour.
I was probably drunk. What did I say?
2 amps at 30 minutes.
Wait a minute.
4
Wait.
amps at 30
Two.
minutes.
Two. I said yeah. I'm 2 amps at 30 minutes. So that'd be 4 amp hours, right? No, wait a minute. 2 amps, 30 minutes.
1 amp.
It's 1 amp hour. See, I told you.
And 4 amps at 30 minutes.
So that'd be
1 amp hour, and then 4
amps at 30 minutes.
That's 2 amp hours.
4 amps
4
at
amps at half an hour.
at
30 minutes.
another 30 minutes.
And then you said to add.
So wait a minute. So that is 2 amp hours. Okay. So at 1 amp hour and 2 amp hours.
Okay. Well, you said to add the amps together and then add the hours together and you get amp hours. So you came out with 6 amps.
Oh, that would be wrong.
Okay. Okay.
Did I? I wonder if I was trying to make a different point. Hang on.
Unless I wrote it down wrong.
Oh, I don't know. There's a pretty good chance that I just screwed it up pretty bad.
I think you were just talking about how if you're pulling a load, how that can vary, and you're just looking at a total.
Maybe. Thank you for coming to my defense. I really appreciate it. There'll be a nice thing in your Christmas gift this year. All right. Let's. So yes, that would have been wrong.
Sorry to interrupt you.
No, it's good if you interrupt me if I say something wrong. I want to correct it.
He was
And-
like, I wasn't sleeping.
You figure I talk for 2 hours a night times 4 hours. What was that, like 10? And then times, I don't know, the 60 weeks this class lasts. I'm going to say a lot of stupid things. Okay, so you got to keep me honest. Where was I here? Hydrometer, 10, 8, oops. Oh, no, I got all messed up. Where's my page 9? 9, there we go. 8, 9. Okay. Let's see. C rate. Want to make sure, in that C rate, I liked one thing I wrote down here. C rate. C rate. So we have the C1 rate. See how that works out. Yeah, it's a C1. The C1 rate. C rate works for discharge as well as charge, although most of the time when it's talking about a C rate, it's talking about the input charge to a battery in most of the books. I can't think of too many discharge. You only discharge the battery at a C rate when you're doing a measured discharge. So for the most part, when you're looking at manuals and they talk about charging it at a C rate, they're going to talk about the charge current going into the rate.
Would that be
To
like
the-
an abbreviation of constant rate, so like constant current charge?
Yeah, we could say, I like that. C stands for constant current. I don't know. CC1 rate. That's what they should have called it. CC1. Constant rate. Yeah, I like that. It's probably where it came from. Constant rate. Never thought about it. Just called it C rate. Maybe it's a charge rate. So,
Well, for discharge.
yeah. Or charge.
Are you
All
sure
right.
it's spelled with a C or is it?
So
S?
here's the thing. So let's just say we have a 35 amp hour battery. Okay, so we'll put example. 35 amp hour. I think I've been writing amp hour backwards now. I'm looking at it. It's like that. That's the correct way. Sorry, not this way. 35 amp hour battery. Well, the C1 rate, I know that's not going to work. C1 rate is 35 amps at 1 hour. Or just 35 amps. They say do the C1 rate, that's 35 amps. I'm just going to be so confident, I'm going to say 35 amps. That is it. If it said the, what else would it be?
17.5.
C.5 rate is what?
70 amps.
Oh, I know, I should do this. This is often C, we'll put 0.1 so you could actually see that it's C 0.1. I'll do that, C 0.1,
So it'd be 350.
3.5, 3.5 amps. Yeah,
That's just hacking confusing.
it's very confusing. That's why I was a little hesitant there. I didn't want to say the wrong thing. The C2 rate, what would that be?
70 amps.
For half an hour.
Yeah, 75 amps. Well, if it is a 35 amp hour battery and it's dead and I charge it at the C1 rate, how long will it take to charge a battery?
1 hour.
1 hour. So if if I'm going to use the C.1 rate, that's how many amps?
3.5.
How many hours will it take? 10 hours. If I'm in a hurry and I want to get out of here and I use the C2 rate,
Good luck.
70 amps.
70 amps.
the 70 amps,
70 or 75?
75.
75.
What I wrote, not what I said. 35, 70. Oh, 70, yeah. Somebody else 75, I just followed. C2 rate 70 amps, how long will it take?
Half
hour.
Half hour. All right, so it's important that when you're doing your projects in the shop and I'm asking you, well, what's your discharge plan, your charge plan? It's great if you want to say C1 rate, but you need to follow it up with something because you can't just tell me, I want you to go charge this battery to C1 rate, please. Because you're going to do what? You're going to go to the machine and you're going to come back and go, yeah, there's no C1 on the machine. Because there's
What do you mean? There's a CI, right? It's
There's a
right
CI,
there.
CI, that's like close enough. So you go to the CI and then you're like, well, now I don't know what to do with the little knobs. So you don't say that. You can, the book and the manual's telling you, because they are writing a manual for all of the batteries that are in that series, and they say, well, charge it at the C.1 rate. Now you have to take it the next step and do what?
Figure out what the amp hour is.
Figure out what the amp hour is and do the math. So you need to tell me that. That's why I always say, well, no, I'm looking for you to write it out like you're telling me how to do it. Because if you have a new guy in the shop, or you an old guy, and you say, go charge at the C1 rate. There's no C1 on the machine. There's a CI. Is that what you mean? So I turned them all the way up. So no, you have to take it the next step, figure out what that is, and then do that. So I think most common, you're going to see like C1, you're going to see the C.1. I like to stick in that range. I don't go to the C2 rate because what happens if you're in a hurry and you throw 70 amps at that battery so you get it done in 30 minutes? It's going to bubble, it's going to overheat, and what happens when it overheats?
Expands.
You're going to
Cells
get
warp.
cells start warping, and they warp, and then they touch each other, they short out, and the battery's dead. So
Charge me at the C10 rate for 6 minutes.
charge it at the C10 rate.
Yeah, I'm in a hurry.
Spoken like a true Marine back there.
It's always better
Thank
to
you
charge
for-
then at a lower rate of charge. Lower C rate. Kevin?
Huh? What?
It's always better to charge at a lower C rate then.
I feel it is. If you're working, excuse me, on my battery, please.
So how,
Do the lower rate.
How often are people like, I gotta hurry up? Like it's really. I guess like
End of the world, man. You gotta get going.
Well, I guess I'm thinking general aviation. So maybe in commercial aviation, it's probably much more.
Commercial is going to be NiCads, so it'll be a little bit
So
different.
it's a little different. So,
Yeah. But we're going to get into that.
so yeah, I want to know if people are just like, I gotta go fly my Aronca. You know.
Oh, wrong plane. They don't have batteries.
Oh, well, okay. Well,
Yeah.
my Piper.
Yeah, I got to fly about one Cessna 150 up to
Like
Willows to
hurry,
get a
like,
hamburger.
Like, how often is somebody just like, come on, man, I only got 30 minutes, charge the fucking battery? Like,
Well, they don't. They just do a jump charge and charge it on the way. Truth? Yes.
So would the 0.1 rate be 3.5 amps for like 10 hours?
Yes.
Okay.
Yes.
Just following
You
the-
better come to me in a hurry. I'll find so much shit.
what if you're like, oh, I don't have the time, but check out that guy over there in that city, and they go fly over there or something like that because they jump started. Can you charge my battery?
All right. Some other terms that I actually had to they're not really airplane-y terms that I'm fine. Maybe they will be someday. So the CCA.
California College of the Arts?
Yes. Cold cranking amps. Cold cranking amps. That is, let me see, the amount of current available for 1 minute. Amount of current available for 1 minute. I have 60 seconds, 0 degrees F. Consider the battery's starting potential when the battery is very cold. So cold cranking amps. Let me see. Discharge rate. The discharge rate is not linear. So we talked about that. Let me see. Oh, I've got a good example here. So the GILL, G-I-L-L, there's a specific battery, the G242 24-volt battery. So it gives a 1 hour rate, also known as the
C1.
very good. C1 rate for this battery is 10 amps. Sounds awful low. The 30-minute rate is what is that? C what?
C.5.
C2.
C2, 20 amps.
C2. 2 times. 2 times the
Times the amperage.
draw. Yes, is that can't be right. 17 amps. Oh yeah, I'm sorry. So it's half the time. You get 17. You would have thought it would have been 20. Okay. And the 60-second 0 degree, also known as cold cranking amps, is 150 amps. So it's not linear. And I also mentioned that behind the scenes, the actual amp hour capacity of the battery is based on how much time?
4 hours.
4 hours. 5 hours. One.
I better write it down. Actual amp hour rating is based on a based on a 5 hour
Is it 4 or 5 hours?
I said 4 yesterday.
I lied, sorry. It's 5. I really think it's 5. Is it 4?
You told me 5.
I'm pretty sure it's 5.
It's just that our
Q&A
battery
question.
What's that?
It's gonna be a Q&A?
Is it me on the test?
Yeah.
Yep, but if I lied to you, I don't know if I have it's something I know.
What's the discharge?
Put 3. Why didn't I, can I get that?
Yeah, I'm pretty sure it's 5.
3 hours.
Well, I don't see it. I think I just did it off the top of my memory here. I'm gonna go with 5. That's what I wrote. Maybe we'll find it. Oh, here it is. I just skipped right over it. 5 hours. Yeah.
5 hours.
Yep.
I think
So-
maybe you mixing up what our project thing is, you know.
Yeah. All right. Let's see if I can finish this off. Power ratings. Okay, 8, 9, 10. Cold cranking amps. Temperature. We covered temperature. What happens to cold temps?
The specific gravity goes down.
All right. Cold temps.
No, it goes up. Specific gravity goes up. Becomes more.
Cold temps. What's my problem with cold temps?
Oh,
Oh,
battery.
okay, more pros than freezing, the battery's discharged.
All right. So first it decreases
Charge rate. Charge acceptance rate.
battery. Oops. Boy, I screwed that up.
Battery.
Performance. So the battery's not going to work as well. When I was a kid, they always had the Die Hard commercials when you watch the NASCAR. They always had the cars in the snowbank. Which one of these cars has a Sears Die Hard and the other doesn't? You know, and then one would the lights would flash, but one would start and drive out of the snow. So, you know, because cold temps decrease battery performance, and if you drive a Tesla, they talk a lot about that, and it really does. Let's see.
Lowers charge acceptance.
Also, higher specific gravity. Higher specific gravity, I already said this, has a higher freezing point. Which is to say, plane A, that guy has or gal, has a battery minder, and that's a thing you can buy that goes on your battery. If you ever go to like a high-end exotic car dealership, all the cars have little wires going to them because they charge your batteries because they don't get used very often. So if you have a battery tender on there that keeps a little trickle charge going, and the guy next to him doesn't, and we get into a hard freeze and the aircraft freeze, this guy with the battery minder has no problem. His electrolyte doesn't freeze. This guy over here with the battery that has a low specific gravity because it hasn't flown in 3 months because it's cold and foggy, his battery freezes over and cracks.
So it's lower, right? Not higher? A lower specific gravity is.
I know, I hate the higher freeze.
Colder has a higher specific gravity, hotter has a lower specific.
Let me see. Higher specific gravity. Let's do this so it's just non-ambiguous. Higher specific gravity will
A lower
not.
specific gravity would be more like water, which is more prone to freeze.
Higher specific 1.3.
Which is good.
Higher
I was old man, you.
freeze as.
Will not freeze as easily as a lower specific
It'll
gravity.
There you go.
discharge quicker too.
Easily. There you go.
Okay.
So, water freezes, specific gravity doesn't. Yes.
Would battery freezing, would that just be a total like destruction of battery because when water freezes it expands?
That is my thought. I've lived in California my whole life, so I never
Fair enough.
experienced it.
If
Yes.
it gets bad enough.
Can the battery freeze like mid-flight?
No, it's too warm. It's in a warm environment usually.
It's also taking charge.
taking a
It's probably
charge.
heating up.
Yeah,
Unless
and that
it's
heats
maybe
it, so
snow
it's got
freezing.
internal heat. My battery's inside the cabin. I mean, it's like on the other side of where the heater is, but a lot of them are up in the firewall where it's hot. So, okay. Let me see.
You got problems with your battery.
What do you do when water's put in a battery? What are you supposed to do? Already said this.
Put on a charger,
Put on charger. We have two methods of charging.
constant voltage, constant current.
Okay.
CP and CI.
Let me see. Charging. That's probably a good place to stop. We'll talk about charging tomorrow.
Yeah.